So now I'm going to go over a few problems to show you how a confidence interval for means is constructed, particularly when we don't know the population standard deviation. That is, sigma is unknown. In this problem, we have bags of chocolate chips, and the claim of this company was that there were at least 1,000 chocolate chips in every single bag. So we want to examine this claim, and so we had students go out and purchase random bags of cookies from different stores. We cleaned the cookies and separated out the chocolate chips and counted the number of chocolate chips in each bag. The data that were then recorded, and the program gave us what they recorded. So there were 10 bags, and this is one bag, this is a second bag, this is a third, and so that's all of our observations. The average then we can calculate, and that's about 12,000 chips. The standard deviation we can also calculate in Excel using a similar method. That's 129. We're going to use both of these numbers, the average and the standard deviation then, in order to construct our confidence interval. Now let's start off by trying to construct a 95% confidence interval. Again, we've calculated the sample average and standard deviation given the data that we collected from 10 bags of chips. We can construct a lower bound and the upper bound. We do so by starting at our sample average, and then we reach up and down some margin of error. So we've added or subtracted this margin of error. The first number is our critical t, and I'm going to show you how to get that in a second. The second number then here, that is our standard error of the repeated sample averages. So we use our sample standard deviation and our sample size to construct that standard error of sample averages. So here I've just plugged in the sample standard deviation. Again, I don't have to square root this because it's already square rooted. I only have to square root the sample size. And that's going to give me a lower bound of about 1,100, an upper bound of about 1,300. So we can be 95% confident that the true average number of chips falls within this range. Now let's talk a second about how I got this critical t. Remember that I want to construct a 95% confidence interval. So I've pulled up my t-table here, and the column I want to go to is the one that gives me an upper tail of 2.5. So if the upper tail is 2.5 and we times that by 2, we'll get our 5%. So that would be a 95% confidence interval. This is the t column that we want to use. Our number of observations was 10. But we want to use the degrees of freedom, which is our number of observations minus 1. So we'll use the t, critical t, that's 2.262. That is for the degrees of freedom 9 for a 95% confidence interval. So again, that is the value that I used to construct my confidence interval here. That's the critical t value of 2.262. Now, we'd like to test the company's claim that at least 1,000 chips are in every bag. However, the parameter that our model looks at is actually the average number of chips. So we say that we are 95% confident that the true average falls within this range. So we're not actually testing the company's claim. The only way that we could test the company's claim would be to check every single bag. Our test looks at the average number of chocolate chips in a bag. So it's kind of like what the typical bag might look like. Some bags are going to have less, and some bags are going to have more chocolate chips. The only way to know if every bag has at least 1,000 chips would be to check every single bag. Therefore, we can't test this claim with our confidence interval because, again, our confidence intervals looks at only the average and not every single bag. The second problem that we are going to look at is the sodium content in hot dogs. Now, to label hot dogs reduced sodium, It means that they have to have less sodium than their regular hot dog counterpart. So we're going to test a sample of hot dogs to see if they have low sodium to make sure that we can actually label them reduced sodium. This company sent 75 hot dogs to a lab to get their product tested, and they measured how much sodium is in those hot dogs. The average amount of sodium was 319 milligrams, and each hot dog obviously varied away from that average, so the standard deviation captured that with a standard deviation of 31 milligrams. Now we want to construct a 95% confidence interval for this sample to see if we can test whether or not they're actually reduced sodium hot dogs. So to construct our 95% confidence interval, we're going to take our sample average and standard deviation and construct the lower bound and the upper bound. Using that sample average as our starting point, we're going to reach up and down a margin of error. This first number here is our critical t, and as you can see, it's different than the last problem, even though we're constructing a 95% confidence interval. The reason why it's different is because our sample size is different. The t distribution changes every time you change the sample size. So we have a differing amount of degrees of freedom, and so our critical t is going to change. I'll show you how I got this in a second. But first, let me show you how I constructed this last term. This last term is the standard error of the repeated samples. So we use our standard deviation sample and divide by the square root of the sample size. Again, I don't square root the standard deviation because that term is already square rooted. When I calculate this out, I get a lower bound of 311 and I get an upper bound of 326.16. Sorry, I had to change that for 1 second there. So let me show you how I got my critical t. Remember that I want a 95% confidence interval, and to get that I have to go to the column that's 0.975. This gives me an upper tail of 2.5%, but since I want two tails, this is the correct column because that's going to give us a 5% total in both my upper and lower tail. The row in which I go to then depends upon my sample size. My sample size was 75, and so I would want to go to the row that's 74. You can see here that there is no 74. There's not even a 70. So I want to choose the one then that is closest. So 80 is closer than 60, and so I'm going to choose 1.99. Now, if you look in your book, it also has a t-table, and that t-table even gives you a more precise critical t. It will give you the precise critical t for degrees of freedom of 74. The critical t given in your book is 1.9925. So that's actually an even more precise number. If I use 1.99, then I would just be off just slightly, and there would be a small rounding error. Here, since we're stopping at 2 decimal places, it's fine to use 0.9925 or 0.99. They'll give me approximately the same answer. So once we've constructed our confidence interval, we can say we are 95% confident that the true average level of sodium is within this range. So now that we have our confidence interval, we're going to use it to figure out whether or not we should label this hot dog as reduced sodium. The regular hot dog counterpart has a sodium level of 465 milligrams. To be labeled reduced sodium, the reduced sodium hot dog must have at least 30% less sodium than its regular counterpart. So there's a maximum amount of sodium that it can have to actually be labeled as reduced sodium. The maximum allowable level of sodium is 30% less than the regular counterpart. So this is going to be 70% times 465, that gives me a sodium level of 325.5. Now, having a sodium level less than this is fine because you've reduced sodium even more. But having a sodium level greater than this means you haven't met the criteria of labeling your hot dogs reduced sodium. Since this value falls within our interval, it's possible that the true average is in fact greater than 325. You could see that the true value could be 326, and then it would be greater than the maximum allowable sodium level. So this package of hot dogs cannot be labeled reduced sodium because they don't meet that 30% criterion or the maximum allowable sodium level. The true average may be greater than this maximum allowable level, and so we can't say we have enough evidence to reject that null hypothesis. In order to be labeled reduced sodium, this whole confidence interval would have to be less than the maximum allowable level. That's the only way they could be labeled reduced sodium. So that's how you construct a confidence interval and use it to run tests and do interpretations. The next thing I want to talk about is this margin of error. This margin of error can be used to determine the sample size beforehand. Let's say we only want to reach up and down one point or $1, then we would need a very particular sample size, and we can determine that beforehand if we know what we want our margin of error to be.